Time. We carry it on our wrists, we chase it in our schedules, we feel it in the beating of our hearts. Yet out there, beyond our skies, time behaves like a restless traveller. It bends, stretches, and slows in ways that feel almost magical. Imagine drifting above Earth, floating silently while the planet spins below you. Your seconds begin to slip out of step with those of the people standing on the ground. And if you journeyed further, near black holes or at speeds close to light, you might find whole years dissolving into mere moments. Tonight we step gently into this mystery. We will not rush, for time is already moving differently here. We will wander like dreamers, pausing to notice how clocks disagree, how gravity weighs down minutes, and how speed itself can reshape the flow of hours. In this story, science becomes lullaby, and the universe whispers its hidden truths. This is not a lecture, it's a journey, one you can close your eyes to and still see clearly. So let us begin with the first quiet suspicion that time may not be equal everywhere. The strange feeling that time may not be equal everywhere. Have you ever noticed how a single hour can feel endless when you're waiting in silence, yet vanish in a blink when you're with someone you love? This simple human feeling hints at something far greater. That time might not be a rigid ruler at all, but a fabric that bends with circumstance. Scientists first uncovered this not in emotions, but in clocks. When they placed precise timepieces in different conditions, they discovered the unthinkable. They ticked differently. Imagine holding two watches, one on Earth, one sent high into the sky, both built perfectly yet soon out of step. It unsettles the mind to imagine. We've built our lives on the assumption that a second is a second everywhere. But what if the very foundation of that belief trembles? The unsettling truth is that the universe itself refuses to march to a single rhythm. If seconds are not universal, then what of our hours, our years, our lives? Could it be that our own journeys are written not just by choices and chances, but also by where we stand in the vast geometry of space? And if time can change in this way, then maybe, just maybe, it's not a background at all, but part of the stage itself, woven into reality's fabric, whispering its own rules. A quiet clock in orbit, astronauts and the puzzle of aging. Far above our heads, astronauts circle Earth aboard the International Space Station. Their bodies move through time just a little differently than ours. The difference is so tiny we cannot feel it, yet the math proves it. They age a fraction slower than their families on Earth. This isn't science fiction. It is the very reason space agencies must account for relativity in every calculation. The astronauts' speed around Earth, combined with the weaker gravity up there, shifts the tick of their biological clocks ever so slightly. Imagine a pair of twins. One stays home, the other spends a year circling Earth. When they reunite, the difference is microscopic, fractions of a second. Yet that small crack in time's armor proves something profound. The flow of life itself can be bent. We rarely pause to consider what that means. If time can shift by orbiting Earth, what about journeys deeper into space or faster through the cosmos? Suddenly the future of human exploration is tied not only to rockets and fuel, but to the delicate weave of seconds and hours. The astronauts become living proof that time is not fair, not fixed, but a traveler itself, always watching where you are and how fast you go. Einstein's first whisper. Time is not fixed, but flexible. Albert Einstein once sat quietly and asked himself, what would happen if I rode a beam of light? It was a childlike question, simple yet impossible. And from that daydream, he uncovered a truth that would rewrite everything. Time is not absolute, it bends with speed and gravity. Before Einstein, Newton's world was one of certainty. Time was a universal drumbeat, steady across all corners of creation. But Einstein whispered a rebellion. He showed that two people, moving differently, could experience entirely different flows of second. It sounds like magic, but it is tested, proven, undeniable. Even airplanes carrying synchronized clocks return home with small mismatches, echoing Einstein's vision. The world changed not only for scientists but for all of us without us even noticing. Think of how bold that is. The very thing we measure everything by, the tick of time, is itself unsteady, curved, pliable. It forces us to rethink not just science, but our place inside it. Einstein's whisper still echoes today. Every time your GPS guides you, it quietly corrects for this bending of time, or else you'd find yourself lost by miles. His thought, born of wonder, now steers billions of lives each day. Gravity's hand pressing down on the rhythm of seconds. Picture yourself standing at sea level with the vast weight of Earth's gravity pulling at your body. Now imagine climbing to a high mountain peak. The difference is invisible, yet the clocks tell the story. Time runs slightly faster up high than down below. Gravity presses not only on stones and bones, but on the very rhythm of seconds. The stronger the pull, the slower time flows. Down in valleys, clocks lag. High above, they race ahead. Tiny differences, but enough to remind us that we live inside a cosmic field, not outside it. Scientists call this gravitational time dilation. It means that near massive objects, stars, planets, even black holes, time itself stretches thin, refusing to move as quickly as it does in emptier places. For humans, these differences are too small to feel, yet across the universe they shape destinies. A planet orbiting close to a heavy star may live centuries, while its neighbor further away witnesses millennia. Gravity, once thought of only as a force of falling apples, is revealed here as a sculptor of time itself, a silent hand pressing down on the seconds, teaching us that time has weight and it can bend. Speed, the hidden thief that stretches time apart. Now imagine yourself on a train, moving faster and faster until it nearly brushes the speed of light. Something peculiar happens, not just to the scenery rushing past, but to your very heartbeat of time. To you, everything feels normal, but to an observer, your clock has slowed. This is the mystery of speed. The faster you go, the slower your time flows compared to those standing still. At near light speeds, minutes, for you, could mean years for those left behind. It's a haunting thought. Speed becomes a thief of shared time. Two friends part ways, one staying on Earth, one racing through the stars. When they meet again, one has aged decades, while the other has barely changed. Yet inside the speeding craft, you would never notice. Your coffee still steams, your breath still fogs the glass. Time is relative, but it always feels honest to the one living it. The illusion only appears when comparing lives across motion. Speed, the silent traveler, hides within every journey. It doesn't just move you through space, it bends your passage through time. Every race, every orbit, every flight carries this quiet stretching with it. The twin paradox, a bedtime story of siblings and stars. Imagine two twins, born under the same sky, sharing the same laughter and the same heartbeat of childhood. One stays on Earth, the other boards a ship that races through the cosmos at nearly the speed of light. When they meet again, one is aged, the other barely changed. Sounds like fantasy, yet it is physics. The faster the traveling twin moves, the slower their clock runs compared to the one at home. The universe, in its quiet rules, gives each twin a separate slice of time to live within. This story unsettles us because it breaks the idea of fairness. How can two lives, once so synchronized, becomes so different simply because one dared to move. It makes us wonder what now really means if it cannot be shared equally by all. Scientists call this the twin paradox, but paradox is perhaps too soft a word. It's more like a mirror showing us that time is not a single river. Instead, it is many streams flowing at different speeds, depending on your path. The twins' reunion is not just an experiment in thought. It is a reminder that every journey changes us, sometimes not only in memory, but in the ticking of our very cells. Earth's gentle pull, already slowing your heartbeat of time. We often forget that we live at the bottom of a vast ocean of gravity. Earth holds us tight not only in body but in seconds. Our clocks deep in this well run slower than they would in emptier, higher places. This means even as we sit quietly, gravity is pressing upon the rhythm of our lives. The effect is tiny, almost invisible, yet with instruments sensitive enough, the difference can be measured and it is real. Imagine standing on a high mountain, looking down at the sea. Your seconds are moving ever so slightly faster than those of the people on the beach. You cannot feel it, yet the universe whispers it into your every breath. The thought is humbling. We live not above time, but inside it, shaped by Earth's embrace. And as you walk through valleys and climb to peaks, you are already stepping into slightly different currents of time itself. So the next time you look up at the sky, remember, even without rockets or stars, your journey through time is already being written differently than the person standing next to you. GPS satellites and why your phone wouldn't work without relativity. Every time you open your phone to find directions, you are unknowingly leaning on Einstein's genius. The satellites circling Earth, sending signals down to your pocket, live in a world where time ticks differently than it does for you. High above, weaker gravity speeds their clocks up. At the same time, their rapid orbit slows them down. The two effects fight, but not evenly. Left uncorrected, the tiny mismatches would throw your location off by miles each day. It is strange to think that our daily convenience, the map that guides us to a cafe or home, depends on the bending of time. Without accounting for relativity, civilization's modern navigation would collapse into error. The engineers of GPS quietly fold in corrections so precise they feel like magic. Every signal carries not only position, but also time, stitched carefully to align Earth's seconds with those racing in orbit. What began as Einstein's dream of riding a beam of light now lives in every journey you take. With a phone in hand, time itself keeps you from being lost. The closer you fall into gravity, the slower your clock ticks. Think of gravity not as a force that pulls, but as a curve that bends. The closer you come to the center of that curve, the harder time itself struggles to move forward. Seconds lengthen, minutes stretch, yet to you inside it, nothing feels wrong. A person standing farther from the pull, perhaps in deep space, would watch your clock crawl. They would see your seconds stretched like taffy, your life moving slower compared to theirs. From your view, everything feels the same, but to them, you are frozen in slow motion. But this is not just imagination, it is measured truth. Atomic clocks carried into mountains or sent up on satellites tick differently than those left on Earth. Gravity writes its script not only in weight, but in time. What does this mean for us? That time is not a backdrop, but a participant. It leans, bends, and changes depending on the mass of the world around you. The closer you stand to something heavy, the more your seconds yield to its embrace. Gravity becomes not only a keeper of your body, but a keeper of your hours. Why mountains have slightly different time than sea level. Here's a gentle curiosity. If you spend your life in the mountains, you will age just a little faster than someone who lives at sea level. The difference is unimaginably small, fractions of a second across a lifetime. But it is there. Up high, Earth's gravity holds you less tightly. Your seconds are freed, ever so slightly, to march more quickly than those in the heavy embrace of the sea. It makes us think differently about the landscapes we walk. Mountains and valleys are not only scenery, they are places where time itself moves with a subtle shift. For climbers, wanderers, and those who live in the thin air of peaks, their clocks drift just ahead of those in coastal cities. The earth writes invisible stories in the very altitude of our homes, and perhaps that is the quiet beauty. Every hill, every plain, every rise and fall of land is not only geography, it is a hidden measure of time's own secret pace. The cosmic ocean where light itself bends under weight. Imagine a beam of light, something we think of as pure and straight, suddenly curving because of gravity. This was one of Einstein's boldest predictions, that massive objects could bend light itself. When scientists watched stars shift position during a solar eclipse, they saw his vision come true. What does that mean for time? Light is the heartbeat of the universe, the speed by which everything is measured. If light can bend, then the pathways of time must bend too, curving gently around heavy objects like rivers, flowing around stones. It feels strange to think that our clocks are not ticking in an empty void, but in a woven ocean. Every planet, every star, every black hole drops its anchor into this ocean, pulling at both light and time together. This is why astronomers can see galaxies distorted into arcs and rings, stretched by unseen masses. The bending of light reveals not only matter, but the very stretching of space and seconds themselves. So the next time you see starlight, remember, it has already bent, curved, and stretched across gravity wells, bringing with it the memory of time's journey through the universe's weight. A thought experiment. Standing at the edge of a black hole. Close your eyes and imagine standing at the rim of a black hole. The pull is so immense that even light cannot escape. Your clock still ticks, your heart still beats, but for anyone watching from afar, your time slows almost to stillness. It's a haunting vision. To you, everything feels normal. To the outside world, you are frozen, trapped in slow motion, never quite crossing that final edge. Time itself seems to hesitate, uncertain of whether to move forward. This strange theatre of time has been tested, modelled, and imagined countless times by physicists. And still, no human has seen it with their own eyes, yet we know the equations whisper the same conclusion. At the edge of a black hole, time does not vanish, it stretches into infinity. For the universe outside, you never fall in. For you, inside, the journey continues, unbroken, silent, unseen by others. It is here, at this edge, that time reveals its most mysterious truth. It is not steady, not universal, but a shifting stage depending on where you stand. The event horizon where time freezes for an outsider. The event horizon of a black hole is often called the point of no return. But to an outside observer, it is even stranger. You never appear to cross it. Instead, you slow and slow and slow until time itself seems to freeze. From afar, you would look like a ghost, stuck forever at the edge, your signals stretched thinner and redder until they fade into silence. To the universe, you are a statue of light, never moving forward. But your own experience tells another story. You fall without pause, without freezing, drifting past the horizon in a single, smooth journey. Two realities unfold at once, one where you are trapped, one where you are free. It is a paradox written by gravity itself. The black hole holds not only matter, but also the very rhythm of time, deciding how it appears to different eyes. This is why the event horizon is more than a boundary in space. It is a boundary in time, a place where perception and reality split into two truths. Falling inward, where seconds dissolve into silence. Beyond the horizon, time loses meaning. Every path curves inward, leading only toward the singularity, the place where our equations tremble and our understanding falters. Here, seconds no longer matter. The closer you fall, the more they dissolve into silence. From the outside, the story of your fall has ended. You are frozen forever at the horizon, but from within your journey is unstoppable, carrying you deeper into the heart of something the universe itself hides from sight. Scientists debate what happens there. Some say matter is crushed into infinite density. Others whisper about bridges to other universes or the rebirth of time itself. But what is certain is this: inside, time no longer belongs to us. It stretches, twists, and finally surrenders to forces we cannot imagine. Every second you once knew is rewritten, unmeasured, unshared. To think of this too long is unsettling, yet oddly peaceful. Perhaps the black hole is not only a grave for matter, but also a resting place for time, where the universe sets down its seconds and lets them sleep. How light struggles crawling out of deep gravity wells. Even light, which we think of as unstoppable, grows weary in the grip of gravity. As it climbs out of a heavy well, its energy drains. Its color reddens. It becomes stretched, like a tired traveler climbing an endless hill. This is called gravitational redshift. To us, it is proof that even light must pay a price for escaping gravity. And with it, time too reveals its weakness. It cannot move freely where mass is strong. Imagine standing on a neutron star, one so dense that light itself crawls outward, barely escaping. The seconds you live there are slower than those far away, wrapped tightly by the star's invisible hand. Every ray of light carries a story. The color it shows, the stretch it holds, is not only about energy, it is about time's struggle against weight. The redder the light, the harder its journey through the grip of mass. So each time we gaze at a star, we are not only seeing its glow, we are seeing the story of time, slowed, stretched, and colored by the gravity it fought to escape. The sun's pull, quietly shifting our clocks each day. The sun does more than warm us, it bends the very rhythm of time across our solar system. Every second here on Earth is slightly stretched by its enormous gravity. The closer you are to the sun, the slower your clock ticks compared to someone drifting further away. It's almost poetic. The same star that feeds our crops and lights our mornings is also pressing gently on the minutes we live. If Earth were nearer, our days would run more slowly. If we lived further out, our clocks would slip ahead. Astronomers measure these shifts carefully. Even signals sent between Earth and satellites feel this difference, corrected by equations we now take for granted. Without it, timekeeping would drift and our technology would falter. What fascinates most is the quietness of it all. No one feels the sun's grip on their seconds. Yet in its gravity, we are held not just in orbit, but in time itself, our clocks bound to its invisible embrace. The sun is not only the giver of light, it is also a keeper of hours, sculpting the hidden pace of days across the solar system. Space stations, where astronauts age differently from Earthlings. High above us, astronauts circle Earth at extraordinary speed. Up there, something curious happens. Their clocks run differently than ours. The weaker pull of gravity speeds them forward, but their great orbital velocity slows them down. Time itself becomes a tug-of-war. For astronauts, the difference is measured in milliseconds, so tiny they will never notice. Yet for scientists, these milliseconds are profound proof that Einstein was right. Time depends on where you are and how fast you move. Think of the wonder. A child born the same day as an astronaut may grow a fraction older simply by staying on Earth. 2 lives, 1 planet, 2 slightly different times. The International Space Station becomes more than a laboratory. It becomes a living clock circling overhead, reminding us that every orbit writes a new story into time's fabric. And though astronauts may laugh at the idea of aging slower, their very journey holds a deeper truth. Space travel does not just change where you are, it changes when you are. Racing jets that prove Einstein right with tiny clocks on board. Not all experiments happen in silence of space. Once, scientists placed atomic clocks on racing jets, sending them eastward and westward across the globe. When the planes landed, the clocks disagreed with the ones left on the ground. The difference was minuscule, fractions of a second. Yet that was enough to confirm what seemed like a dream. Speed bends time. The faster you move, the slower your seconds pass compared to those who stand still. It is eerie to imagine. A pilot sipping coffee mid-flight is already living in a slightly slower stream of time than their family waiting at home. Invisible, unfelt, yet undeniably real. This experiment showed us that relativity isn't only about stars or black holes. It happens here, on Earth, in the roar of engines, in the quiet hum of atomic clocks. In that moment, science stopped being abstract. It became part of human journeys, every flight, a reminder that the very act of moving reshapes the passage of your hours. A second isn't always a second, the paradox of definition. We often say just a second, as though it's the smallest, most reliable unit of time. But the truth is stranger. A second here is not always equal to a second there. Location, speed, gravity, all decide how a second unfolds. Scientists define a second with exquisite precision, using the vibration of atoms. Yet even those vibrations change depending on conditions. An atom deep in gravity vibrates slower than one floating higher, far from Earth's pull. This means our definition of time is always conditional. It works beautifully for us, but it is never universal. A clock that is perfect here may falter if moved to a mountain or sent into orbit. It feels unsettling. We crave certainty, yet the universe insists there is none, not even in the seconds we trust so dearly. Time is not a rule, but a participant in reality, reshaped by the stage it plays upon. So when you glance at a ticking clock, remember, it is keeping Earth's time, not the universe's. Somewhere else, even right now, a second is living differently. Why universal time is only an illusion we agree upon. To live together, humans needed a shared measure of time. We built calendars, carved hours, and declared the world should follow one rhythm. We created universal time. But the truth is, it is only an agreement, not reality. The universe does not honor our definitions. Time flows differently in mountains, in orbits, in the grip of stars. Yet we smooth over these differences to keep our trains on schedule and our lives in harmony. This illusion is necessary, yet fragile. Without constant corrections, our networks would unravel. Every GPS signal, every satellite communication quietly adjusts, stitching together the fabric we call one time. In truth, there is no now that covers the universe. There are only countless nows, each flowing at its own pace. We live inside one, but out there others are moving differently, endlessly. Universal time is our story, our compromise. The cosmos, however, tells a stranger tale, one where every star, every orbit, every traveler moves to its own hidden clock. Galaxies, gravity, and their hidden time signatures. Every galaxy is more than stars. It is a great whirlpool of gravity, bending not only space but also time. Deep in the core, where black holes and dense clusters live, seconds run more slowly than in the fragile edges of the spiral arms. Imagine two civilizations, one near the heart of a galaxy, one far in the outskirts. Their histories would unfold at slightly different paces. Millennia, for one, may not align with the same for the other. Time itself becomes part of their cosmic geography. Astronomers see galaxies as luminous paintings, but hidden within is a rhythm, a pattern where gravity sculpts not just the shape of stars, but the very tempo of their unfolding futures. The arms of a galaxy stretch like dancers, yet each step carries its own hidden clock. Gravity pulls at their seconds, shaping the music of their existence without them ever knowing. It makes us wonder, when we gaze at galaxies through telescopes, are we not only looking into space but also into countless timelines, each moving at its own secret speed? Cosmic strings of space-time weaving the universe's fabric. Some scientists imagine the universe as more than empty blackness. They speak of space-time as a fabric woven like cloth, and within this cloth there may be threads, cosmic strings, stretching across vastness, carrying immense tension. These strings, if they exist, bend space and time around them. A traveller passing near one would feel seconds stretch, pathways twist, as though time itself were tugged by an invisible loom. It is a poetic thought, the universe not as emptiness but as tapestry, every star and every life embroidered upon it, and cosmic strings perhaps acting as the hidden stitches. If time can bend, can it also tear? Could these threads of space-time ripple, vibrate, or even snap, changing the rhythm of the cosmos itself? Physicists chase this mystery with equations that sound like myth but behave like truth. And so the universe becomes not a void, but a quilt, woven, rippling, holding secrets in every unseen fibre of time's cloth. How time slows near neutron stars, dense as eternity. Neutron stars are among the strangest objects in existence. Imagine something so heavy that a teaspoon of its matter outweighs mountains. Their gravity is so fierce that time itself bends, seconds dragging as if they're chained. Standing on a neutron star, if such a thing were possible, your minutes would stretch long compared to those living on Earth. To distant observers, your life would appear slowed, painted in heavy strokes of gravity's hand. Neutron stars spin, beam, and pulse like lighthouses across space. But beneath that glow lies the deeper story. They hold time hostage, making it crawl in their embrace. Astronomers measure this not with human eyes, but with atomic precision. Every pulse, every flash carries evidence of time's distortion, a cosmic reminder that mass decides how fast the clock should move. So in the presence of neutron stars, time itself becomes dense, heavy, eternal, reminding us that even seconds can bend under the weight of the universe's most compact hearts. The slow dance of pulsars, clocks written in starlight. Pulsars are neutron stars that spin with incredible speed, flashing beams of radiation like cosmic lighthouses. Some turn dozens of times each second, perfectly regular, becoming the most precise clocks in the universe. These beams reach Earth across millions of years, yet remain steady. Astronomers rely on pulsars as timekeepers, measuring cosmic distances and testing theories of gravity. They are the universe's natural metronomes, keeping time with light instead of ticking gears. Yet even pulsars feel the stretching hand of gravity. Their rhythm can shift when locked in the pull of other stars, proof that even the best cosmic clocks are bent by space-time. It feels poetic that stars, once blazing with life, die and return as keepers of time. From birth to collapse to lighthouse, they never stop marking the seconds of eternity. When we listen to pulsars, we are hearing time itself sing. A cosmic heartbeat echoing through darkness, steady, mysterious, unyielding, curved space-time. Why geometry writes the laws of time? Einstein taught us that space and time are not separate. They are one fabric, space-time. And the geometry of this fabric decides how time flows. It is not clocks that rule seconds, but curves, shapes, and invisible bends. A planet curves space-time around it. A star bends it further. A black hole folds it almost beyond recognition. And with each curve, time itself changes its pace. The straighter the path, the faster the seconds, the deeper the bend, the slower the minutes. We live in this geometry without ever noticing it. Our lives unfold inside curves we cannot see, yet our bodies, our thoughts, our memories are carried by their quiet influence. Physicists describe this with equations, but for us it is more than numbers, it is existence itself. Every choice we make, every breath we take, happens in a curved landscape that shapes our hours. So geometry is not only for lines and circles on paper, it is the hidden artist of time, sketching how long or short a life may feel within the fabric of space-time. The faster you move, the longer your journey takes. Speed doesn't only carry you across distance, it changes the way you live through time. A runner on Earth experiences seconds nearly like everyone else, but a ship racing near the speed of light stretches those seconds into something entirely different. For the traveler, nothing feels unusual. Their meals, their conversations, their heartbeats all flow as normal. But to those they left behind, the traveler's time has slowed, stretched thin by motion. Hours for them might become years for others. It is unsettling to imagine speed granting longer life, yet at the cost of separation. You gain time in your body, but lose it in shared memory with those who remain. This effect is not theory alone. It has been proven with clocks flown on planes, satellites, and spacecraft. Each time, the faster-moving one returns slightly younger than the still one. So speed, in its hidden way, does not just move you forward, it bends your story. It can make journeys longer, not in distance, but in the very hours you carry inside. Spaceships dreaming of near-light speeds and their toll on years. If we ever build ships that race near the speed of light, we will unlock journeys that feel short to the crew, but long to those waiting on Earth. A trip across the stars could take just decades aboard, but centuries might pass at home. This idea both excites and frightens scientists. It means interstellar travel is possible in principle, but at the cost of losing the world you left behind. The travelers return to a different Earth, one aged far beyond their own faces. It is a story both hopeful and tragic. Hopeful because the stars could be within human reach. Tragic because home would slip into history before your eyes. Yet some see it as destiny. Perhaps future generations will accept this price, trading the comfort of shared time for the wonder of touching new suns, breathing air beneath foreign skies. These imagined ships remind us to chase the stars is also to chase different time, to live lives unmoored from the calendars of Earth. Light speed as the cosmic speed limit. No matter how much energy we pour into rockets, we cannot break one rule. Nothing with mass can reach or exceed the speed of light. It is the universe's boundary, the great barrier beyond which time and space refuse to let us go. As you approach this speed, the energy required grows infinite, the seconds stretch longer, and the distance ahead becomes unreachable. Light itself moves freely, but anything heavier must crawl behind, never catching up. It feels almost unfair. Why place the stars within view, yet guard them with an unbreakable limit? And yet this limit protects the universe's consistency. Without it, causality, order, and even memory would collapse. So light becomes both messenger and gatekeeper. It shows us the universe's history but denies us the chance to surpass it. The speed of light is not just velocity, it is the very heartbeat of existence. Every beam we see is proof. There are boundaries no technology can erase, lines the universe itself has drawn in its hidden laws. If you could ride a photon, what would time feel like? Here is a thought experiment that stirs the imagination. If you could shrink yourself into a photon and ride on its beam, what would time feel like? For light, there is no experience of seconds. Its journey is instantaneous from its own perspective. A photon leaving a star today and reaching Earth in 1,000,000 years does not feel 1,000,000 years. To it, the departure and arrival are one and the same. For us, stretched in slower clocks, it is a long and patient voyage. This idea is dizzying. It suggests that light lives outside our experience of time. It does not wait, it does not age, it does not endure. It simply is. What then does it mean for us, built of matter, to live in stretched seconds while light passes effortlessly across eternity? It whispers that time itself may be a property of matter, not of existence itself. Riding a photon may be impossible, but imagining it opens a door to seeing time not as universal, but as a cloak wrapped only around the slow, heavy bodies like ours. The universe's expansion, stretching not just space, but time itself. The universe is not static, it is expanding. Galaxies drift away from one another, carried by the stretching fabric of space-time, and with this expansion, time itself seems to stretch, growing thinner, slower, wider with every passing eon. What does that mean for us? It means the further we look, the older the light becomes, stretched into red whispers across the cosmos. The very passage of time is written in the glow of distant galaxies. As expansion accelerates, scientists wonder if time itself will change in ways we cannot yet imagine. Could the universe eventually stretch so fast that time loses its meaning? For now, expansion is a quiet background, like a deep breath slowly drawn. We do not feel it, but telescopes see it. Every star, every cluster, drifting further apart, carrying their clocks with them. So the universe expands not only in distance, but in time. Every heartbeat we live unfolds in a cosmos where even seconds are carried outward, stretched thin across infinity. Cosmic background radiation as a frozen memory of time. When we look into the night sky with special instruments, we see a faint glow, the cosmic microwave background. It is not starlight, it is a memory, a fossil of the universe when it was just a child, only 380,000 years old. This glow carries the rhythm of that early time, stretched by billions of years of expansion. Its waves are now cold whispers, but they still tell us how fast time moved when the universe first cooled into light. It is remarkable. The oldest photograph ever taken, not by us, but by reality itself. Every pixel of that glow shows how time unfolded in its first moments. For cosmologists, this background is a clock frozen into space. It reminds us that time was once tighter, faster, more condensed, before the universe stretched into the wide silence we now drift through. So when we listen to this cosmic background, we are not just hearing radiation, we are hearing the first seconds of time echoing endlessly, how the early universe ran on a different clock. The early universe was hot, dense, and alive with collisions. Particles swarmed so tightly that time itself seemed to move differently, compressed into rapid flashes of creation and destruction. 1 second after the Big Bang, matter and energy were nearly indistinguishable. At 3 minutes, atoms began to form. By hundreds of thousands of years, light finally traveled freely. Each stage unfolded on a cosmic clock so unlike ours. For us, a second feels gentle, steady. For the newborn universe, a second was an explosion, a transformation, an age compressed into the blink of an eye. Scientists study this era not through memory, but through mathematics, tracing how fundamental forces cooled, separated, and allowed time as we know it to exist. It reminds us that the second is not eternal. It was forged, like everything else, in the fires of the early universe, and it has been stretching, evolving, and slowing ever since. The Big Bang, when time itself was born. We often imagine the Big Bang as a blast in space, but the truth is subtler, stranger. It was the birth of space and time together. Before it, there was no ticking, no before, no after. At that first instant, time itself unfolded with the universe. Space expanded, matter formed, and seconds began to exist. The universe did not start in emptiness. It created the very stage upon which emptiness could exist. And this is perhaps the most unsettling idea of all, that time had a beginning, that the story we live inside is not infinite backward but has a first chapter. The Big Bang, then, is not just about galaxies and stars. It is about the clock of existence beginning its very first tick. To speak of before the Big Bang is to step into silence, for there was no before. There was only timelessness, waiting to give birth to time. Before time. Can physics even imagine such a place? If time began at the Big Bang, what does it mean to ask about before? It is like asking what lies north of the North Pole, a question without a ground to stand on. Some physicists suggest that time may have curled, looping back on itself, leaving no before at all. Others imagine that our universe is one bubble in a larger foam, where other timelines may exist beyond our reach. It stretches the mind to think of timelessness, no seconds, no hours, no change, pure existence, without rhythm, waiting for time to be born. Religions and philosophies have long touched this mystery, speaking of eternity as something beyond our human clocks. Science now finds itself at the same edge, gazing into a silence it cannot measure. Perhaps the greatest humility comes here, to admit that the birthplace of time may forever lie beyond our grasp, hidden in the dark between equations and dreams. Quantum mysteries. Do tiny particles feel time like we do? Step into the quantum world and time grows even stranger. Particles blink in and out of existence, appearing in two places at once, defying the steady march we know so well. At this scale, seconds do not flow evenly. A particle's behavior seems timeless, ruled by probability rather than sequence. Cause and effect blur, as though time itself becomes a suggestion rather than a rule. Physicists wrestle with this paradox. Does time exist at all for these tiny things, or is it only something that emerges when countless particles come together to form a larger world like ours? The quantum realm whispers that time may not be fundamental but born out of entanglement, observation, and the weaving together of many possibilities. So when you look at the ticking of your watch, remember, it may not be the smallest truth. It may be the illusion of countless quantum mysteries working together to create the rhythm of your life. Time dilation inside the quantum world of uncertainty. In the quantum world, time seems to hesitate. Particles may exist in superpositions, both here and there, both moving and still, until observed. Seconds do not flow cleanly, but ripple as if the smallest building blocks of matter are undecided about when they exist. Physicists speak of time dilation at this level, not as a ticking of clocks, but as probabilities stretched across outcomes. A particle may wait endlessly or decay instantly, and only when measured does time reveal a chosen face. It feels unsettling. Does time only exist when we look? Is reality itself waiting for an audience before unfolding? This uncertainty means that the very rhythm of quantum life does not mirror our own. Instead, it is a shimmering fog, where moments blur and seconds refuse to march in order. Perhaps time, at its root, is not a ruler, but a shadow, emerging only when countless particles join together to form something large enough to live, breathe, and notice. The paradox of entanglement and timeless communication. Quantum entanglement is often described as spooky action at a distance. Two particles, once connected, seem to share a bond so deep that distance and even time cannot break it. Change one particle here, and its twin responds instantly, even if it's light years away. No signal passes, no delay is seen. It is as though they share a secret language that ignores the flow of time itself. This challenges our deepest beliefs. How can something happen without waiting, without cause, chasing effect across seconds? It is a crack in the walls of time, showing us another possibility. Some wonder, is this communication truly instant, or does it mean that entangled particles are simply never apart, always part of one timeless whole? Entanglement whispers that time may not be as fundamental as we believe. Perhaps what feels like distance and delay is only an illusion, hiding an underlying unity where everything is connected beyond seconds. Wormholes, shortcuts that play tricks with clocks. Wormholes appear in theory as tunnels through space-time, shortcuts that could link distant places instantly. If such portals exist, they would not only bend space, they would warp time. Imagine entering a wormhole and emerging not just far away but at a different moment. The clocks you carry may disagree with those waiting on the other side. For travelers, time could be skipped, folded, or stretched in unimaginable ways. To us on Earth, years might pass while you experience only moments. Or the opposite. You could arrive before you left, tangled in a knot of chronology. Physicists debate whether wormholes can truly exist, or whether they are too unstable to hold. But in their mathematics, time is not a line but a sheet, one that can be folded and pierced like paper. And so wormholes remain in our imagination, symbols of how fragile our sense of before and after really is. Could time loops exist inside extreme cosmic tunnels? The idea of time loops has fascinated philosophers and storytellers for centuries. In the mathematics of relativity, certain space-time curves, like those near rotating black holes or hypothetical tunnels, could allow paths that return to the same moment. Imagine walking forward yet arriving back in yesterday, or sending a message that arrives before it was written. These loops sound impossible, yet in equations they are not forbidden. But the universe guards itself. Most physicists believe some deeper law prevents these loops from being real, protecting causality, the order of cause and effect, from unraveling. Still, the thought remains haunting. Could there be hidden regions where time folds back on itself, invisible to us, but real in the universe's deeper structure? Perhaps somewhere far beyond our reach, there are places where time is not a river, but a circle, where endings and beginnings meet in endless embrace. Hawking's playful thought, imaginary time beyond our sense. Stephen Hawking once proposed a daring idea. What if time itself could be imaginary? Not imaginary as in unreal, but as in another kind of dimension, turning time into something that behaves like space. In this view, the universe may have no true beginning or end, just like Earth has no edge, only a surface that curves smoothly. Time, then, may not stop or start, but loop gently, avoiding the infinite walls we fear. It is playful, almost mischievous. Hawking asked us to see time not as a relentless arrow, but as a shape, something curved, hidden, and more flexible than we imagine. Imaginary time is not something we can feel with clocks or calendars. It is a language of mathematics, one that helps describe the strange origins of the cosmos in ways our senses cannot. And yet, even if abstract, it opens a gentle doorway. Maybe time is not just what we live through, but also what we live within. a dimension with shapes we cannot yet touch. Does the future already exist, waiting for us to arrive? One of the strangest questions of physics is whether the future is already real. Some theories say the universe is like a book, its pages already written from first to last. We simply read through them, 1 second at a time. From this view, tomorrow is not being created, it is already there, waiting. We only move into it, like travelers following a path carved long before we step upon it. The idea is unsettling. If the future exists, are our choices illusions, or are we characters who still write our story, even if the ending is already bound? Some physicists embrace this view because it fits with relativity, past, present, and future, all existing side by side, stitched into space-time itself. A now here is not the same now elsewhere. It suggests that time is a landscape, not a flowing river. If true, then every moment of your life still exists, your childhood, this instant, and your distant old age, all present in the fabric of the cosmos, waiting to be touched like stars in the sky. Block universe theory, all moments as eternal neighbors. The block universe is an image of reality where time is laid out all at once, like a map. The past is one region, the present another, the future still another, all existing together, none more real than the rest. In this vision, time does not pass. Instead, we move through it like someone walking across a field. The field does not change, it is already there. Only the traveler's steps give the sense of movement. This theory comforts some. If all moments exist forever, nothing is truly lost. Every memory, every loved one, every joy still lies somewhere eternal in the block. But it also chills others. If everything is already fixed, then do we have freedom? Is choice a song we only imagine we sing? Or is free will the very act of moving through the block, choosing which path we notice, even if all paths exist? The block universe is not proven, but it whispers something powerful. Maybe time is not fleeting, but eternal, every second held forever in the structure of reality. Why free will feels real, even if time is written. If the block universe is true, you might wonder, do our choices matter? Are we puppets in a play already rehearsed? Yet inside the human heart, free will feels undeniable, as solid as the ground beneath our feet. Perhaps both can be true. The script may be written, but the experience of living it is fresh, unknown, and open. A reader may know the ending of a book, but the characters still act as though their choices are real. Philosophers suggest that free will might not be about changing the timeline, but about experiencing it, about being conscious actors inside a play that, from outside, is already complete. And so when you choose to love, to forgive, to step forward, you are still shaping the life you live, even if, from the universe's perspective, that life is already etched into space-time. This paradox may never resolve fully, but perhaps the truth is simple. Free will feels real because it is real to us, and that is enough to live by. Dreams as our mind's rebellion against linear time. In dreams, time loses its order. Minutes stretch into days, or hours collapse into a single breath. You may live an entire lifetime in sleep only to wake and find that barely moments have passed. Scientists say dreams are the brain's theatre, stitching together memories and emotions. But they are also a rebellion against the strict march of seconds. In dreams, past and present merge, and the future can slip into the stage early. This is why dreams feel both real and impossible. They do not obey linear time. They create their own, fluid and free, untethered from clocks. Perhaps our minds, built inside a universe of relativity, carry a hidden awareness that time is not as rigid as we pretend it to be. Dreams may be our nightly reminder of that truth. And so each dream becomes more than fantasy. It becomes a glimpse into a world where time is flexible, layered, and far less orderly than our waking lives suggest. Why sleep itself feels like time travel each night. When you drift into sleep, something curious happens. Hours vanish. You close your eyes at midnight and wake at dawn. Yet to your mind, no time has passed at all. Sleep is our simplest form of time travel. Your body continues to live, to breathe, to heal. But your awareness leaps across the gap, skipping whole stretches of hours as though they never existed. It is humbling to realize we live this mystery every night. We treat it as normal, yet it is one of the deepest experiences of time's strangeness in daily life. Sleep proves that consciousness is what anchors us in seconds. Without awareness, time flows silently, unmeasured, forgotten until we reawaken to the ticking of the clock. So, each night, in every bed across the world, humans slip into their own private wormhole of sorts, leaping forward in time, re-emerging hours later with no sense of the journey, just taken. Animals and their different clocks, flies, turtles, whales, every creature lives inside its own rhythm of time. For a fly, life is a rapid heartbeat, wings beating hundreds of times each second, days compressed into what feels like a lifetime. For a turtle, the world is slower, breath stretched, movements patient, centuries possible. Whales drift through oceans with songs lasting hours, echoing across miles. Their sense of time must be vast and fluid compared to ours. Each species is a traveler, carrying its own clock, written in biology as much as in physics. It reminds us that time is not universal even here on Earth. What feels like a moment to one life form may be an eternity to another. If we could step into their minds, we might find a fly perceiving our movements as impossibly slow, or a tortoise seeing our rushing days as mere sparks in the dark. Nature whispers through them that time is not just science, it is experience, and every living being lives a unique version of it. Human perception. How fear and love stretch moments. For humans, seconds are not equal. In fear, a moment stretches endlessly, falling, crashing, waiting in panic. All make time crawl, each heartbeat a thunderous second. Yet in love, in joy, in wonder, hours vanish as if stolen away. Our brains measure time not with clocks, but with attention. When something demands focus, time feels slower. When life flows smoothly, time dissolves into a blur. This is why a single day of travel feels long, while years of routine vanish in memory. It shows us that perception is as powerful as physics. Time may bend in black holes, but it also bends in the human heart. Even memories reshape time. Painful days linger longer in recollection, while gentle joys slip into soft flashes. Love and loss both leave fingerprints on our personal clocks. So time is never only out there in the cosmos, it is also here, inside our feelings, stretching and collapsing with every moment we live. Memory, the human machine that edits our timeline. Our memories are not perfect recordings. They are editors cutting, rearranging, and sometimes inventing. In this way, our past is not a fixed sequence, but a story we continuously rewrite. Think of childhood. The years may feel long and vast, filled with summers that seemed endless. Yet as adults, the same span of time feels compressed, fleeting, slipping by almost unnoticed. Memory itself is what shapes this illusion. Neurologists say the brain compresses repetitive experiences, saving detail only for moments that stand out. This is why unique events feel longer in hindsight. They occupy more space in the story we tell ourselves. In a way, memory is our personal relativity. It stretches or shrinks time, deciding which hours matter and which fade. Two people may share the same day, but their memories of it can be worlds apart. And so memory becomes not only a record of time, but a sculptor of it, painting our lives with strokes of choice, attention, and emotion. Why boredom slows time and joy speeds it up. Everyone knows the feeling of sitting in a waiting room where minutes feel like hours. Yet a joyful gathering with friends can erase entire evenings in what feels like a blink. This isn't imagination, it's how our brains perceive the flow of seconds. When we are bored, our minds pay attention to every detail: the ticking of the clock, the shuffling of feet, the silence of the room. Each small thing is marked, stretching the perception of time. When we are engaged, details vanish and time runs smooth and fast. This strange duality reveals that the passage of time is partly a construction of awareness. Attention stretches moments, while flow dissolves them. Philosophers and scientists alike have noticed this. The saying "time flies when you're having fun" is not a cliché. It is a window into the mechanics of perception and brain chemistry. So next time you feel time dragging, know that it is your attention magnifying seconds, and when joy arrives, time folds and vanishes like sparks in the wind. Gravity of emotions compared with gravity of stars. We often think of gravity only in terms of planets and stars. Yet emotions have their own pull, bending our perception of time just as surely as black holes bend light. Grief makes days feel endless. Joy makes hours disappear. Anxiety suspends moments in unbearable stretches. In both science and spirit, gravity and emotion share a truth. They warp the flow of our lives. Where physics bends time with mass, the human heart bends it with feeling. Both are invisible, yet both shape our experience profoundly. Consider the way heartbreak makes nights last forever, or how falling in love can turn hours into seconds. These are not illusions, they are the emotional relativity of our lives. Just as stars sculpt the fabric of space-time, our emotions sculpt the fabric of memory and perception, deciding which days we will carry long and which will vanish quickly. So perhaps emotions are our personal gravity wells, shaping not just how we feel, but how we live inside time's unfolding story. If you lived on Mars, how different would time feel? Mars has days, called sols, that are just a little longer than ours, about 24 hours and 39 minutes. At first glance, that seems small, but live there long enough and you'd begin to notice your life drifting out of sync with Earth. A Martian week would not match an Earth week. Your birthday would not fall on the same day back home. The years would stretch, almost twice as long as ours, changing the rhythm of aging and seasons completely. Time on Mars would still feel normal to you. Your heart would beat, your meals would follow the sun, your body would adapt. But compared to Earth, your life would move differently. Imagine a family split between planets, letters, signals, celebrations all slowly drifting out of rhythm. The same day would not mean the same thing anymore. Mars would teach us that time is always relative to the world beneath our feet. So to live on Mars is not only to leave Earth's soil, but also to leave Earth's clock, stepping into an entirely new measure of existence. Alien civilizations and their cosmic calendars. If alien civilizations exist, they may live beneath suns of different colors on planets with days far longer or shorter than ours. Their calendars, their sense of time, their very lives would unfold in ways we might find unrecognizable. Imagine beings under a dim red sun where days last weeks and nights stretch into months. Their idea of a moment could mean years to us. Or imagine a planet spinning rapidly, where a day is only hours long. Their lives might feel breathless and fast. Their calendars would not match ours. Their histories, their generations, even their memories would be measured against rhythms we could not share. Time itself would be cultural, woven into their identity. Perhaps this is why contact feels so distant, because not only do stars separate us, but time itself may run differently for each world. So when we dream of aliens, we should not only ask what they look like, but how they live their seconds. For to know their time is to know their soul. Could advanced beings escape time altogether? Some imagine that civilizations far older than ours may have discovered a way to step outside of time itself. No longer bound by seconds or hours, they would exist in a state we cannot truly picture. To them, past and future would be the same, available to see, to touch, to move between at will. They would not live in time, but around it, as though standing outside a river while watching it flow. This idea feels like science fiction, but physicists whisper about dimensions beyond ours, places where time is not linear but layered, accessible in ways we cannot reach yet. If such beings exist, they might appear godlike to us, not because of power, but because they are unshackled from the ticking that binds our lives. To them, our struggles would look like shadows trapped in glass. Perhaps one day humanity will glimpse such freedom. Or perhaps it is forever beyond us, a dream whispered only in the equations of physics and the myths of spirit. Spiritual traditions that whisper about timelessness. Long before science measured time with clocks, spiritual traditions spoke of timelessness. Mystics across cultures described moments of eternity, states of being where time dissolved, and one felt connected to something beyond the hours of ordinary life. In meditation, prayer, or deep contemplation, people often report losing track of time altogether. Hours pass in what feels like minutes, or minutes stretch into eternity. These states hint at an inner truth. Time is not only external, it is also within us. Ancient texts describe eternity not as endless duration, but as a quality beyond duration, something always present, always whole. It is less a line and more a stillness. These whispers across cultures remind us that time, while scientific, is also deeply human. We live it not only with clocks, but with spirit, memory, and perception. Perhaps that is why both physicists and mystics, in their different languages, arrive at the same edge, the sense that time is not ultimate, but only a doorway into something greater. Meditation as a way to bend inner time. Close your eyes, breathe deeply, and sit in stillness. In meditation, something curious happens. Minutes soften, hours dissolve, and the ordinary sense of time loosens its grip. You step into a space where seconds feel irrelevant. Neuroscientists find that the brain in meditation enters rhythms unlike waking life. Awareness grows sharper, but the usual markers of time fade. Practitioners often say they feel timeless, suspended in a calm beyond measurement. It is not that time stops. It is that the mind releases its constant need to measure. Without the counting of moments, experience flows differently, more like water than ticking gears. This is why meditation is called a practice of presence. In presence, there is no past or future, only the richness of now, infinite and alive. Perhaps meditation offers a glimpse of what the universe knows already, that time is not absolute, but flexible, and within us lies the ability to step outside its ordinary march, even if only on a while. Death and the idea of stepping out of clocks. Death has always been seen as a crossing, but perhaps it is also a stepping outside of time. Our bodies are bound to clocks, heartbeats, breaths, circadian rhythms, but what if the essence of us is not? For some, death is the end of hours, the quiet stopping of the body's clock. For others, it is the doorway into timelessness, a place where seconds no longer chase one another in endless succession. Many spiritual traditions describe death not as darkness, but as freedom from the ticking of moments, a return to something that has always been present beyond time. It is hard to know what lies there, yet in imagining it, we glimpse the possibility that our truest selves are not limited to the hours we count here on earth. Perhaps death is not an ending of time, but a release from it, like stepping out of a river and realizing you were never the water, only the one flowing within it. If the universe ends, does time end with it? Physicists speak of possible endings for the universe: heat death, collapse, or tearing apart. In each scenario, the question lingers: what becomes of time? If all stars fade and energy spreads thin, seconds may stretch endlessly, every event slowing until nothing changes. Time would continue, but empty, hollow, stripped of meaning. If instead the universe collapses, seconds may race, pulling everything together into a final instant, a closing book where time ends in a single breath. Or, if space tears apart in acceleration, clocks may simply lose their grip. Time could dissolve as distances stretch beyond recognition. The unsettling thought is this: without change, without motion, without matter, does time exist at all? Or is time only as real as the events it measures? The heat death, where seconds spread into infinity. The heat death is the quietest ending, a universe so stretched and cold that energy cannot flow. Without flow, there is no change. Without change, there is no measure of time. Imagine galaxies faded, stars extinguished, matter itself scattered into whispers. The universe would not explode or collapse. It would simply drift into silence, stretched across eternity. In such a place, seconds would lose their meaning. Nothing new would happen. Every clock would tick, but with nothing to measure. Each tick would be empty, hollow, meaningless. It is both terrifying and oddly peaceful, the ultimate stillness where the universe becomes a frozen sea without currents. In that silence, perhaps time continues forever. Or perhaps it simply ceases, having no reason to exist, without change to carry it. Cycles and rebirth. Maybe time is a loop, not a line. Some traditions and some scientists imagine time not as a straight arrow, but as a circle. The universe may not end once, but repeat, expanding, collapsing, and being born again. If this is true, then time is not lost. Every moment we live will return again, endlessly, in infinite cycles. Death would not be final, but simply one curve in the circle, leading to rebirth. It is a comforting thought that nothing is truly gone, that time itself regenerates, looping over and over like a heartbeat in the cosmos. Philosophers call this the eternal return. Physicists call it cyclic cosmology. Both whisper the same truth. Maybe endings are only beginnings and beginnings only endings. If so, then perhaps every moment is eternal, destined to return again in another cycle of the universe's breathing. Returning to Earth. Your watch ticking, your heart steady, but the universe still bending your every moment. After all this wandering through black holes, galaxies, and timeless mysteries, we return to Earth. Here, your watch ticks steadily, your heart beats softly, your days seem ordinary. Yet even here, time is not absolute. Gravity pulls at your seconds. Speed nudges your minutes. Emotions stretch your hours. Memory edits your past. And still you live as though time was simple and steady, because that is how we survive. The truth is stranger and more beautiful. You are not only moving through time, you are woven into it, part of its bending fabric, a participant in its flow. Every breath you take is shaped by the universe's hidden laws, by space-time itself stretching and curving around you. Even sitting still, you are part of the great dance of relativity. So as you close your eyes tonight, Remember, your seconds are never ordinary. They are cosmic, bent by stars, stretched by gravity, and carried on the same currents that shape galaxies. You live in the mystery of time itself.